So today I want to go over prime factorization, and the method I want to use to describe prime factorization is called the factor tree, right? And the factor tree allows us to find the prime factorization of a number, right? So we'll end up with just all prime numbers, and prime numbers are numbers like 2, 3, 5, 7, 9, 11, 13, etc., right? So prime numbers, right? The key to being a prime number is it has to be divisible by 1 and itself. Those are the only two numbers you can divide it by, right? So I'll show you an example of the factor tree in the next slide. Okay, here we have 50, right? And 50, right? We can think about 50, right? The factors of 50, two numbers that multiply together to give you 50. Maybe 25 and 2. It's like having 2 quarters, right? Okay, cool. All right, so now we have 25. So, right, 25 can be thought of as like 5 times 5, right? So now we have 5 times 5 gives us 25, and 25 times 2 gives us 50, right? Notice 5 can't be broken down anymore, and neither can 2, right? So therefore, right, we have found our prime factorization of 50, right? So in other words, 5 times 5 times 2 gives us 50, right? And notice all these numbers, right? These are all prime. And that's why it's called the prime factorization, right? So we're finding pretty much all the prime numbers that are multiplied together to give the number, right? Let's do more examples of factor tree. So now we have 96, right? We have 96, and it can be any two numbers multiplied together to give you 96, right? The number that I'm thinking of now, right? You can multiply 3, right, by 32, right? Because if you have 3 sets of 32, that's 96. Well, 3 is already a prime number, so now I have to look at 32 and see, what multiples, what two things can I multiply together to give me 32, right? And you may be thinking 8 and 4. Okay, cool. 8 times 4 gives me 32, right? So now I have 8 and 4. They can both be broken down more, right? So 4 can be broken down to 2 times 2, and 8 can be broken down into 4 times 2, right? And again, this 4 can be broken down into 2, going off the screen there, but 2 times 2, right? So the answer, right, of prime factorization for the number 96, it's 3 times 2 times 2 times 2 times 2 times 2. So we have 1, 2, 3, 4, 5 2's and a 3. So 2 times 2 times 2 times 2 times 3 gives us 96, right? So this is the prime factorization of 96. So there should be another 2, excuse me. Right, so 5 2's, 1, 2, 3, 4, 5 2's, and a 3 gives us 96. Right, and you can always multiply this out to test if you got the right number. Awesome, let's move to the next problem. So we have 520. And now we have to think of two numbers multiplied together to give you 520. And this one's not so bad, right? I mean, we have 52 and 10, right? Because if we just multiply by 10, we just add a 0, so we'll get 520, right? So now we have to break down 52 and 10. Well, 10 breaks down into 5 times 2, right? And then we have 52, right? And 52, right? It can break down into 2 times right? Well, 2 times 25 is 50, right? So 2 times 26, right, is 52. So now we have to break this down further. 13 times 2, right? So now to get the prime factorization of 520, we're literally going to take all of the prime numbers. So 2, 13, 2, 5, and 2, right? So let's list that out. We got 2 times 13 times 2 times 5 times 2. And that will give you 520, right? And notice, right, that all these numbers are prime, right? That's how you know if you did it right. That and these numbers will add up to, you know, the number that you originally tried to factor. Awesome. So now we have 264. And it's even, so I know it's going to be divisible by 2. So that's a good place to start. And 2 times 1 is 2, so I'm going to put a 1 here, right? 2 times 3 is 6, so I'm going to put a 3 here. And 2 times 4 is 2, so I'm going to put a 2 here. Right, so I have 2 times 132 gives us 264, right? Now 132, I can further break that down, right? And what do you know? It ends in a 2, so I know it's going to be divisible by at least 2, right? I can try 2 or 4 or any number like that, right? So I have, right, 132. If I break that down by 2, 2 goes into 13 6 times with 1 left over. 2 goes into 12 6 times. So I have 66 times 2 gives me 132, right? I can break this down, right, by 3. Say 3 times, well, 3 goes into 6, right, 2 times, right? So I had 22. And then this further breaks down to 11 times 2, right? So now I have 2, 2, 3, 11, and 2. So the prime factorization of this number would be 2 times 2 times 3 times 11 times 2, right? And like I said, all these numbers are going to be prime. And when you multiply them together, the product should equal 264. Awesome. So now I have 328, right? I need two numbers multiplied together. That would give me 328, right? So we know it's even, so we can break it down by 2, right? But it ends in an 8, and the first two numbers are 32. So I think it will be faster to go by 8 in this case, right? So 8 goes into 32 4 times, goes into 8 1 time. So now we have 8 and 41. 41, right, is a prime number. We can't break that down. So now we have to break down the 8 and the 4 times 2. And we could break down the 4 as 2 times 2, right? So our prime numbers in this case would be 2, 2, 2, and 41, right? So our prime factorization is going to be 2 times 2, 1, 2, 3, times 41. And this will give you 328.